So, to set the stage for virtual smart cards that I'm going to talk about, I want to remind you a little bit about the physical smart cards. They are credit card-sized plastic, or generally credit card-sized plastic cards with a built-in microprocessor. They have interfaces, contact interfaces, and that's the contact plate. That's not the chip, the yellow thing. And it can also be interfaced in a contactless way with using the antenna. A funny thing when I worked for the world's largest smart card manufacturer for many years, and we rolled out the American Express Blue in America, and we did a customer survey to check if the customers understood the great capabilities of the smart card. And one of the questions they asked was, what's smart about it? And I think it was something like 60% pointed to the hologram. That's of course also smart, but it doesn't have anything to do with the CPU that is on the smart card. So why the smart card is useful for security purposes is because it's tamper-proof and it's capable of doing crypto operations. It's been the most secure practical authentication device for users for more than 20 years. It's now supported by all operating systems, and most applications also that has some security purpose also supports smart cards. And this is important, that the interfaces to this two-factor authentication device has already the interfaces in place when we go and look at virtual smart cards. So the virtual smart cards is basically software emulating a physical smart card. Wave Systems introduced it. I don't know exactly when, but they became more popular when Microsoft released virtual smart cards in Windows 8, and that was about 2011. Virtual smart cards need to be administrated basically in the same way as physical smart cards. You have tools on the individual machines where you can do basic things like load certificates onto it or generate keys. But for a larger scale, you will need a card management system to make it practical. There are several products in the market. You already mentioned Microsoft. Wave Systems are no longer a player in this field. Charismatics has a virtual smart card, and of course Versasec has a smart card, virtual smart card. So the TPM is important for the virtual smart card, and that is to give the virtual smart card, that is from the start a software product, but to give it the hardware characteristics. Most PCs now have the TPM on the motherboard. It's hard actually to find a PC without a TPM nowadays. The TPM is able to do key storage and crypto operations. So the TPM seals the connection between the virtual smart card and the host, because you can no longer take this software piece and move it to another host computer. It is still not quite capable of doing everything that the best smart cards in the industry can do. It has, even the TPM version 2.0 doesn't have support for some symmetric key algorithms and not the elliptic key algorithms for public key crypto either, I think. So to secure devices, there are several components that have been introduced, and it could maybe be interesting to clarify there a little bit. The TPM that I just mentioned is the Trusted Platform Module. It's a piece of hardware that sits on the motherboard. It's separated from the rest of the processing system, and it's typically housed on a PC. The TEE, the Trusted Execution Environment, is a secure area of the main processor. It works like the TPM, but it's not physically isolated from the CPU. And it's generally found on mobile devices. And the SE, the secure element, is a tamper-resistant secret store, a key storage, that its main purpose is not to do cryptographic operations, but rather to store secrets. It's also generally found on mobile devices. I mean, you can, by the definitions there, see the differences, but the SE could, of course, be a part of the TE concept, which, but all on mobile, but TPM on PCs generally. So, back to my area here. So making the virtual smart card appear as a physical smart card, you have to do by emulating a physical smart card. And this can be done either by making middleware, like the PKCS11, CSP, or Smart Card Mini Driver on the Windows Smart Card stack. Or you can go in on a lower level, and that would be on the PCSC Smart Card Reader level, and make your own driver to emulate the smart card. All these have been tested, and for our product, we chose to go on the reader level to get to maximize the operability of the solution. So we basically fool the system that we are a smart card reader. So, just-in-time virtual smart cards. It means that the virtual smart card can be made available exactly when you need it. It could be a temporary user that walks in that you want to issue a card to quickly. It could be someone who forgets their physical smart card, and you still want them to be useful that day, without sending them home to get their smart card or issue another physical smart card. You can then use a virtual smart card, or you can have very short validity periods of your credentials on the smart card, and therefore want to interact with the virtual smart card frequently. To do this, it requires, of course, a management system and something that we call remote security device management, which enables what this image is trying to show, these services to be in contact with the central system at these points. So you couldn't, of course, get the just-in-time virtual smart cards without the connection, because you can't push it out without the connection between the components. The interface to this virtual smart card is generally the credential provider on the PC. So we enabled the interface to the virtual smart card directly from the login prompt. So you can get to administration tasks from the login prompt, like unblocking the virtual smart card or issue new virtual smart cards when needed. Other features of the remote security device management function is the complete life cycle of the virtual smart card, of course. You can have a centralized audit trail, and you can do central batch issuance, which if you worked with smart cards your whole life, you know that's very frequent, that you want to issue all the cards in a central location, and that would of course be difficult when the card is a part of the user's desktop or laptop. So that's when you need this remote security device management feature. Virtual smart cards maintain the free key properties of a physical smart card, and that is non-exportability, because all private information on the virtual smart card is encrypted using the TPM on the host computer. It cannot be used on a different computer with a different TPM. Additionally, TPMs are designed to be tamper-proof and non-exportable. So a malicious user cannot reverse engineer an identical TPM and install the same TPM on different computer. Isolated cryptography, that means that the TPMs provide the same properties of isolated cryptography offered by the physical smart cards, and unencrypted copies of private keys are never available outside of the TPM chip, and all cryptographic operations are done inside the chip. Anti-hammering, that is basically handling incorrect PIN entries and what policies that you want to enforce there, like if the smart card should get locked after a certain invalid PIN entries, or if it should be if there should be a delay until you can enter your next PIN, and how the virtual smart card should be unblocked if you block it with invalid entries. So 3 key properties of the physical smart cards are maintained with the virtual smart card. Getting down to the cost aspect. A smart card project, of course, needs cards, readers, and very frequently also smart card printers. So the hardware costs are a good part of a smart card project generally. With virtual smart cards, no additional hardware is needed, so that's a saving right away. Maintenance cost with physical smart cards, generally there is some replacements needed. I mean, wear and tear of a physical card they will be replaced eventually, and lost cards will also create maintenance cost. And another cost with physical cards is maintaining stocks of physical cards. That's often forgotten. If you have a distributed big organization, you will need to have stocks of blank cards so you can issue them at all those locations. That you don't need with virtual smart cards. So what we've seen in the projects we've done with the virtual smart cards is that the typical savings for the whole project is about 50% compared to doing physical smart cards. And tend to get happier end users as well, because it's more convenient not to have to bring your card with you every day. So, with all the advantages we discussed, it might seem like physical smart cards would be obsolete, but that's of course not the case. Depending on the requirements of the project, physical smart cards are still often the only alternative for our customers. And examples of such requirements would be security, as we mentioned before. The security level of a physical smart card, most of the time, depending on, there are many different types of smart cards, of course, but the good kind, the security level of the physical smart card exceeds the virtual smart card. And for full compliance with security regulations, the physical smart card is often required. For physical security and for physical access control, the physical smart card is still often the better alternative. I mean, doors, access controls to doors have the interfaces to work with contactless cards. The card also has a slightly more convenient form factor than having to show your PC or whatever device you're having. Visual identification is also an important part. The physical card has the capability to act as a corporate badge with a photo of the card holder printed on it. And this is a proven method of securing a workplace to let people walk around with badges. I mean, we have something like that today, but not with a picture. Roaming use, meaning that users are sharing terminals, is also not practical with virtual smart cards. And this, for example, in healthcare is very common, that the doctors are walking into one room and examining one patient and logging into a computer and checking something there, and then they go into the next room. Then the smart card is very convenient, while a virtual smart card is slightly more complicated. I mean, the just-in-time feature could potentially follow the doctor, but it needs to be very quick then. So we've seen a lot of success with virtual smart cards lately. Most of our projects, our larger projects around the world, has some part, I mean, maybe for temporary users or as a backup, they use virtual smart cards. But we don't think that it will replace the physical smart card as the only or winning two-factor authentication device. That's something that we all, or for my business, is very important to think about. What will the winning two-factor authentication device be? And analysts have for many years predicted that the smartphone will be that device. It hasn't really happened yet, but the smartphone, of course, has a lot of advantages. I mean, our cards in our wallet, we're not at all as fond of as our iPhone. They've done some research that people tend to not go back and pick up their wallet when they forget it when they walk from home, but if they forget their phone, they will take buses and flights and everything to get back home. So that's of course good, but we're not just fond of our phones. We're kind of in love with them and married with them, and we want to keep them for ourselves. I mean, we don't want often we don't want our employer to tell us what phone we should have, and we don't want the employer to take ownership of that phone. So companies that have used the phone as the authentication device see this problem. So we're looking at the future and alternatives, and Apple are looking at new and cool watches. Maybe that would be something, or maybe biometrics, or maybe something completely new and disruptive, and that's what we're looking forward to. It looks really good on the top watch. Yeah, I think that's about it. I'm ready for questions if you have anything. Otherwise, we can look at some case studies. Any questions on virtual smart cards?
First, can you access the virtual smart cards using PKCS 11 on mobile devices like Android or iOS? How do you use them?
Okay. That, Marcus, using PKCS 11 on a Android device. I don't know. I would have to take that question back to my CTO and see how that would work. I mean,
is there some other method?
to use it on an Android device?
Yeah, for example.
Yeah. There are several interfaces to crypto stores on Android devices. I know that, but I don't think they're PKCS 11 enabled. I haven't done that much Android programming. Sorry. Yeah.
My impression is that the TPM kind of, you guys store your secrets, but when you're doing this application on top of it that decides, for example, does it lock down or slow down, is that operated inside the TPM or is that actually in the unprotected operating system side?
Okay, so in our case, if we go back to the smart card stack here. So the software that we do is on the reader level. So the software tells the system when a card is inserted, when the just-in-time feature says, I'm going to push a smart card here. It doesn't do the crypto. The crypto you offload to the TPM. So the keys will not be extracted or can't be extracted from the TPM, only used within it.
Extract the key, but can I, for example, hammer it if I override your driver?
Oh, if you overwrite my driver and use the TPM instead of, or some software on the PC that attempts to use the TPM. Yes, but the TPM is protected by itself. It has those anti-hammering properties that I've talked about. I mean, it's pin protected. Yeah, you can use the TPM for other purposes. I mean, you can use it for BitLocker or something like that. But it has this pin protection. Yes. So it's much like an HSM or something like that. If you're connected to it, you can of course use it, but hopefully it requires some sort of authentication to do so. Any other questions? Yeah.
You mentioned several use cases where this wouldn't be useful and work. What are some?
Glad you asked. I have some use cases here. Good question. So, for example, one of our customers is a European public transport company. They employ 300,000 employees worldwide. They have 90,000 managed virtual smart cards. So you can see that the individual management without a system would be kind of complicated. It would be a very busy system administrator walking around issuing those. They used to use RSA tokens, and now that they switched to virtual smart cards using TPMs. They had originally planned to go with Wave systems, but they closed down, and we stepped in. That's how we got the deal. They looked at other alternatives in the market, and one of our advantages was that we support Windows 7, and Microsoft starts with this functionality from Windows 8. That's one of our most important.
And so what exactly are the cards? What are they being used for? Is it authentication? Is it contact?
Good question. Yeah. So the main use case that we come in contact with is for authentication, logging onto your desktop. But you can of course use it for encrypting your hard drives and for signing and encrypting emails and all that nice stuff. Anything else? Any other questions? No? Oh, there we go.
Related to signing encrypted emails, do you have a use case where you have users who need to sign encrypted emails on multiple devices because this is fine and physical device?
That's a good point. Yeah, that would be well, more a physical smart card use case. Yeah, and it that's not a good fit for virtual smart cards at all, actually. Good point. Yeah. Okay. Well, thank you very much.